All right, I hope you had as much fun at the swimming as I did today. It was a pretty good day. It was a very hot day. I still haven't quite managed to cool down yet, and I'm looking forward to a shower very soon. But there's some maths to be done first, and I love that ZMAN, no, I know it's ZMAN, has come up with another question for us. Let's see how we go. Just trying to check and clarify what is involved in the elimination method. So you can solve the problem the other way, but the elimination method is your friend. It's going to save you time. It's actually easier. So let's make sure we can do it. I'm going to show you both ways because why not? And hopefully that will help you. Remember, there's also the other YouTube video that you can check out. The link is on our page and you'll be able to get some help there. But here we've got two equations. I'm going to call this one equation 1 and this one equation 2, as I always do. All right, so I've got my two equations. Not very exciting so far. Now, step 1. Down here, multiply one or both equations to make the coefficients of one of the variables the same magnitude. What I mean by the magnitude is that it could be positive or negative the same number. So if it was 47, it could be one could be 47, the other would be negative 47. They could both be positive 47, they could both be negative 47. Any of those would be fine as long as they're the same. In this case, they're not going to be 47. The easiest way to do this is you can see, look, I've got 3x and 14x. There it is. 3x and 14x. Here I've got 3y and 12y. 3, it's a factor of 12. So let's do it that way. I'm going to multiply equation 1 by 4 and just write down what I get when I do that. So I've got 12x plus 12y equals, and 4 57s are 228. In the other one, I've got 14x plus 12y equals 254. So I'm going to call this 1 prime, little dash afterwards. Americans call it prime. It actually works pretty well. It's a good way to distinguish. It's just a different version of 1, so the prime just indicates it's still equation 1, but I've just rearranged it or done something to it in some way. In this case, multiplied it by 4. Now, if I subtract one of these equations from the other, the 12y's are going to disappear, which is what we want. Because I've got 14x's in equation 2 and only 12 in the first equation, I'm going to go equation 2 and I'm going to subtract from equation 2 1 prime. What does that give me? It gives me 14x minus 12x is 2x. 12y minus 12y we know is nothing. 254 minus 28 is 26. Now, I don't want to know what 2x is, I want to know what x is, so I divide each side by 2, and I've got x equals 13. So I've done step 1, done step 2, and solve for the remaining variable. We've done step 3. What's left? Take this value, substitute it into either of the original equations to solve for the other value. So I'm going to sub it into 1, so I'm going to say sub 13 for x in equation 1. I'm not going to use 1 prime this time. I'm going to use just 1 because it's smaller numbers, makes it a bit easier. Therefore, 3 times 13 plus 3 times y equals 57. 39 plus 3y equals 57. Subtracting 39 from each side, 3y equals 18. And dividing by 3, y equals 6. And then it's lovely if you can write this little concluding statement. Your communication will be beautiful. So the simultaneous solution, and if you can't be bothered writing out simultaneous solution, if you just wrote the simultaneous solution, I would not mind at all. If you just wrote solution, did I say simultaneous twice? Probably. It's been a long, hot day. The simultaneous solution is 13, 6, or you could write it as x equals 13 and y equals 6. Either of those ways would be fine. I promised you I'd do it 2 ways. So there we did it. Worked fine. We got an answer. We could check it in the other one. What do we got? 13 14s, 169 plus 13, 182 plus 6 12s are 72, 182 plus 72, 254. Yep, so we know I got it right. Do that checking. It's always good for you. You don't have to write it down, but get in the habit of doing it in your head. Let's do it again. This time I'm going to equate the coefficients of x. 3 and 14. 3 is prime. It's not a factor of 14, so I just got to find the product of them, which is 42. So the first equation, I'm going to go equation 1, and this time I'm going to multiply it by 14 to get a 1 prime. And if I did that, I would have 42x plus 42y equals 1457. So what's that? 784. Let's hope I got that right. No, is it? 788. Now I'm going to have to slow down and do it. What am I multiplying by? 14. So we've got 570 plus 200 plus 28. 770, maybe 98? You, of course, would have done it on your calculator by now. Clearly, it's getting a bit hot for me. Let's go again. 14 times 57. 570 plus 228. 798. I think I'm right with that. There you go. It's good for you to practice doing those sorts of things in your head. You'll get faster at it. You'll find it easier. You'll be faster than me because it's more important for you. You've got exams coming up. I'm done with them. I don't need to worry about them anymore. You still have those things ahead of you. So practice it. It's not very hard, and if you do it every day, it'll become very easy. Equation 2. I'm going to multiply by 3. That way I get 42x plus 36y, and this time I've got 750 plus 12, 762. When they work out nicely like this, where the greater number of y's is on the top, when I do subtraction, when I subtract these, 42x minus 42x disappears, the x's are gone. 42y minus 36y is 6y. Nice if you can put brackets around them just to show you doing the whole equations being subtracted. And here I've got 798 minus 762 is 36. Dividing by 6 gives me y equals 6. That's promising. That's what we had before. We've got that. I'm going to again substitute into equation 1. This time I'm going to say sub y equals 6 into equation 1. So you can see you can just write it as y equals 6, or before I wrote it slightly differently. I think, can we see it somewhere? Oh, sub 13 4x. So sub x equals 13 would have been just as easy. Anyway, subbing 6 into equation 1, I have 3x plus 3 times 6 equals 57. 3x plus 18 equals 57. Subtracting 18 from each side, 3x equals 39. Dividing by 3, x equals 13. And you can write your same concluding statement, do your checking, but we've already done that on the right-hand side. So that's the elimination method. 4 steps, pretty easy to follow. The advantage of it is you don't have to work with ugly fractions. And as we know, we're better off with integers than fractions. So why not do that? I hope that helps. ZMAN, 2 questions in the collaboration space. Everyone else lift your game. You can't have him beating you. Surely that has shamed you into action. We'll see. Catch you in the next one, guys. Bye.